Today we are going to talk about how to write equations of geometric sequences. Now, a geometric sequence is a pattern that requires you to either multiply or divide, but technically it's just about multiplication. And that's how this equation is written. A sub n equals a sub 1 times r to the power of n minus 1. Now, a1 refers to the first term of the sequence. So let me give you a sequence. This here is an example of a geometric sequence. 3, 12, 48, and let's just assume it goes on forever, this pattern. And the pattern here is to go from 3 to 12, that is times 4, and to go from 12 to 48, you also multiply by 4, and we assume the pattern repeats forever. That's a geometric sequence because you're going to figure out you got to multiply by the same number over and over again to get to the next number. Hence, this sequence is geometric. Now, when it says first term, that is referring to the first number in our pattern. That's why it is 1. That's why it's a sub 1. That's A1. Now, this pattern that we see here, times 4, that is what we call our ratio, which we represent with the letter R. And that's what this one is right here. That represents ratio. Now, the n is a variable. That's the n, the nth term. Okay, that can be the 4th, the 5th, the 6th, the 7th, the 2nd, the 3rd. It doesn't matter. The nth term, the one we do not know yet. All right, and we'll make use of this equation in a bit. So our first goal is, can we figure out all this information that we need so we can write an equation? So to write this equation is pretty easy. We have everything we need. A sub n, we're going to leave that alone. A1 is the first number in our pattern. And A1 in this problem, the first number is 3. So we're going to write 3 times a common ratio. A ratio that is shared by the pattern over and over again, times 4, times 4, times 4, times 4, times 4, times 4. So it is 4. That is our common ratio, 4. And we just copy that to the power of n minus 1. And we are done creating an equation for this pattern. For example, if I want the second number, let's talk about how to use this. If I want the second number, then I will put A, and instead of n, I want the second number in the pattern, I'm going to put 2. Wherever you see n, and I'm about to see n again soon, like this one right here, that would be 2, because I want the second number in the pattern. And the answer should be 12, because that's the second number in the pattern. Two minus 1 is 1. 4 to the power of 1 is 4. And we know 3 times 4 is 12. So as you can see, the second number, or the second term in the pattern, is 12. And you can go on forever to check if you want the third number. Hence I put 3 for n. And you can check it yourself, and you will see that that will become 3 minus 1 is 2. And don't forget your PEMDAS, your order of operations. You have to square first before you multiply. So you have to do 4 square first, which is 16. And 3 times 16 is 48, which is the number that we expected. So as you can see, this right here, this equation that we came up with, will describe the pattern in the sequence, even the ones that are not listed. Alright, so you can find the 10th number in the pattern pretty quickly by plugging in 10 there. And we have our answer. Alright. Now, in order to type this in Schoology, you're gonna type it in just like you would type in a calculator. Alright, so this is already written for you in Schoology, and what you need is what's on the right side of this equation, which would be 3 parentheses 4, and like I said, you would write it like you type in a calculator, a caret sign for the power, and you want all of that as a power, so you need to put parentheses around it, to the power of n minus 1, and this is the part that you have to write in Schoology.